Hi, let's calculate the total angular deflection for light coming into a system of two mirrors at an angle phi between each other and then reflecting back out. So what we're going to say is that this light ray strikes our first mirror at some angle theta. And from the law of reflection, it reflects off that mirror at that exact same angle theta. Well, these mirrors are tilted at some angle phi with respect to each other, so that light ray that bounces off the first mirror will strike the second mirror at a slightly different angle, which I am going to call, for reasons of making things look prettier later, 90 degrees minus gamma. And that light ray is going to reflect out at that same angle of 90 degrees minus gamma. So if I were to take this light ray coming in and extend it all the way beyond the mirror, and take this light ray going out and trace it back all the way into the mirror, those two rays are going to intersect at a point. And what we want to do is find the angle rotating counterclockwise from our original travel path to our exit path. And that angle we're going to call beta, and the partner in making up this straight line we're going to call alpha. So a line has a total angle of 180 degrees, so alpha plus beta has to equal 180 degrees. Now, I called this angle 90 degrees minus gamma because on this ray and on that ray I have a total of 4 angles that I'm adding together in order to get that 180 degree line. Here I have theta, and then I have 2 more uniformly spaced angles that would each be 90 degrees minus theta. So these 2 evenly spaced angles on the interior are my angles gamma, so that gamma plus 90 degrees minus gamma plus 90 degrees minus gamma is going to sum up to 180 degrees. Just like theta plus 90 minus theta plus 90 minus theta sums up to 180 degrees. Now, there are 2 triangles that I've created. One triangle is going to involve my angle phi. And in this small triangle going from here to there and back, I have an angle of 90 degrees minus theta plus my angle phi plus my angle gamma, and for a triangle, the 3 angles have to add up to 180 degrees. I also have a larger triangle made up with my angle alpha. I have this angle gamma and this angle gamma added together. If I follow this line up to the bounce between the mirrors and then back, so that would have alpha plus 2 gamma, and here I would have 90 minus theta plus 90 minus theta, which would give me 180 degrees minus 2 theta, and I add that plus alpha plus 2 gamma, that adds up to 180 degrees. So let's start simplifying some things. So here I have 180 degrees on both sides of the equation, which means that 180 degrees cancels out. And I'm just left with 0 equal to 2 gamma minus 2 theta plus alpha. Well, I want to find this angle beta, so if I can find my angle alpha, beta is just 180 degrees minus alpha. Well, alpha is going to be, I can add 2 theta to both sides, I can subtract 2 gamma from both sides, and factor out that 2, so alpha is equal to 2 times theta minus gamma. So, if we can find this angle theta minus gamma, then we can find our angle beta. So, let's take a look at our next triangle. So, again, I can subtract 90 degrees to get one measurement of angle on each side, and then I have gamma minus theta plus phi is equal to 90 degrees. Well, if I subtract theta from both sides, subtract or add theta to both sides, subtract gamma from both sides, and then subtract the 90 degrees, I can rearrange that equation to say theta minus gamma is phi minus 90 degrees. So alpha is 2 times theta minus gamma. So alpha is going to be 2 times phi minus 180 degrees. And beta is 180 degrees minus alpha, 180 degrees minus negative 180 degrees gives me 360 degrees minus 2 times the angle phi between the two mirrors. Now here's something that's a really neat consequence. Say phi happens to be exactly 90 degrees. Well, if phi is 90 degrees, 2 times 90 is 180, 360 minus 180 is going to be 180. And what that means is the light that strikes this first surface would end up returning parallel to the original direction of travel. So anytime you have a right angle mirror, any light that reflects off one of that surfaces of that mirror is going to reflect straight back in the way that it came. And this type of mirror is known as a retroreflector. And retroreflectors are used really often in safety vests. You may have noticed if you've ever seen like a safety vest, it looks like no matter sort of how you look at it, you see light coming at you. Well, regardless of what angle your headlights are striking that object or your flashlight is striking that object, there is light from your headlights or your flashlight reflecting straight back to you, making sure that you would be able to see that object that has that safety coating on it. Thanks for watching.